All right, the next one is number 11. I'm gonna go find number 11. Here it is. So okay, so this is something that we just went over today in section 1.8. I got 4 different functions, f, g, h, and k, and I have 5 problems to do. 11. The functions f, g, h, and k are defined for all real numbers as x as follows. The first one they want you to find is do f minus g of x. So simply, you need to just subtract f minus g. We're going to subtract them. So I'll do x squared plus x plus 3. Guys, that's what f is. That minus g, negative 3x squared plus 1. Okay, notice I put them in a nice parenthesis. Now let me get them out of the parenthesis this time. X squared plus x plus 3. But then the second one, imagine we're distributing negative 1, or we are actually subtracting a negative 3x squared, subtracting a positive 1. So signs inside will switch. Okay, so we're going to have negative times negative is positive 3x squared. And then negative times positive is going to be minus negative 1 right there. So let's combine some like terms. What are some like terms? I see there is an x squared. There is a positive 3x squared. They add up to 4x squared, right? Any other like terms do we see here? I see there is positive 3 and a negative 1. But before I write that first, let me go ahead and just write this plus x. This one didn't have any partner, so it's just all alone. Plus x. But then if I add plus 3 and negative 1, that will get me plus 2. So here is my first answer. Subtracting f minus g, and that was just what it is. All right, now this one, g times h of negative 3. I told you that you can just go ahead and find g of negative 3 and h of negative 3. And guess what you're going to do after getting those answers? You will simply multiply them, okay? So let's plug in negative 3 into g. That's what g is. So very carefully, it will be negative 3 times negative 3 squared plus 1. When you are evaluating this, make sure you square first. Do not multiply first. If you square first, you will get negative 3 squared positive 9. And if I simplify this, I will get negative 27 plus 1. So g of negative 3 is negative 26. If I plug in negative 3 into h this time, let's plug it into that function. That will be negative 1/3 times negative 3 plus 1. Negative 1/3 times negative 3. So these will all cancel out, leaving me with just 1 plus 1. And that is 2. So I'm almost done. All I now need to do is just multiply these two numbers. So final answer is negative 26 times 2, negative 52. All right, we're doing good. Next one. Ooh, now this one isn't multiplication though. Now, this was multiplying, this closed circle. This is multiplying, but that means composition. That means composition. So don't you do, this is not the same thing as h of negative 1 times f of negative 1. That is not what we are trying to do here. We're trying to do a composition of two functions. So let's do that. First, let me rewrite what that means. What is h of f? Oh, that circle almost looked close. It's like h of f of negative 1. That means you need to do h outside. H is the outside function. And inside, you will evaluate f of negative 1. So remember I told you to work from inside out. So you will need to figure out what this is first. So right here, let me go ahead and find what it is. What is f of negative 1? If I plug in negative 1 in here, that will be negative 1 squared plus negative 1 plus 3. So what's that going to be? That is positive 1 minus 1 plus 3. That is 3. So what I just found, this 3 will replace this gray highlighted f of negative 1. So that's the same thing as h outside of 3. So all you need to do is plug in 3 into h. Where is h? Notice h is right here. H is negative 1 over 3x. X came out to be 3 plus 1. And let us evaluate that. 3's cancel out over here. The 3's are gone. I get negative 1 plus 1. Oh, what's the final answer? The final answer is 0. That's fun. So think I'm gonna have like just one compositional function on your exam 1. Maybe there's another one. If you find one, and if you have a question, you have to let me know, okay? Now, next one, find the value of f over k of 2. They want you to just find f of 2 and then divide that by k of 2. I'll do that in a single line, okay? So let's plug in 2 into f of x. F was that squaring function, squaring, adding that, and then adding 3. So that is f of 2. And I didn't memorize it, guys. I was looking at this right here. I remember plugging in -1 over there. So I just plugged in 2 everywhere I saw -1. So, okay. What about the g? K. I don't remember what k was. K was... Oh, ew. Okay. I'm going to have to plug that in right there. So 2 times 2 squared minus 5 times 2 minus 3. It's not that bad, I guess. It's not that bad at all. All right, let's evaluate this. I'll try to do this much without a calculator as possible. Do I really need to? I don't need to, guys. I don't need to. You don't need to. All right, let me type this in. 2 squared plus 2 plus 3. I got 9 for the numerator. The denominator, let me type this in. Unfortunately, you're not looking at my hand, but I got a scientific calculator on my hand, and I typed it in, and I got -5. Now, promise me that if you see me making a mistake, you have to email me, okay? Or just leave me a comment so that I can go and fix my videos, okay? But that is how you would do f over k of 2, okay? You just plug in 2 into f and k, and just put it on top of each other, and that is how you do it. Now, the last one is a little bit more confusing, domain. This is a nice review problem of what we did in section 1.3 when we did domain of rational functions. Let me first write down what f over k is. F over k is equal to, f is what? Sorry, I zoomed out a lot. X squared plus x plus 3 is on top of the fraction. Denominator is k, 2x squared minus 5x minus 3. Now remember, something in mathematics, you are not allowed to have 0 in the denominator, right? So denominator cannot be equal to 0. Whatever that makes the denominator 0, that is going to be the excluded value. That is the value that we will not allow to have. What's the denominator here? Denominator is this 2x squared minus 5x minus 3. So I'm going to go ahead and say this cannot be equal to 3. I showed you a little different factoring method earlier in class, remember? I call that the slide and divide method. I'll do the same thing over here. 2 times 3. I temporarily multiply that leading coefficient to the constant. I get x squared minus 5x minus 6. I'll just factor and then I'll put that not equal to 0 part later. Factor this. X and x. What times what is 6? Well, but they must add up to -5. This is a tricky one. Because let me try. 3 times 2. 3 times 2 is 6. And if I make them both negative, I will have them to add up to -5. But if they're both negative, negative times negative is positive 5, 6. So they're not going to give me -6. So it's not -3 and -2. It must be something else. Maybe 6 and 1. If I make 6 negative, 1 positive, then -6 times 1 is -6, which matches that one. And -6 plus 1 is -5, which matches the middle one, so we got it. But remember, this is that slide and divide method. Now I need to divide both of these numbers by 2. And remember in class I told you, if it divides, you divide, and that's how you simplify it. Like 6 divided by 2 is what? 3. That's good. But I cannot divide 1 by 2. 1 divided by 2 is what? 0.5. So if it's going to give you a decimal, you bring that bottom up. I think in North Carolina, when I taught it, they called it bottoms up method. So instead of x plus 1, you're going to have 2x plus 1. And that is how I kind of showed you how we can factor this step by step. But now, let's go ahead and solve this for 0. Okay, let's go ahead and solve this for 0. First one. X minus 3 cannot be 0. Therefore, if I add 3 to both sides, I got the first excluded value that x can't be equal to +3. Let's do this one. 2x plus 1 cannot be equal to 0. subtract 1 from both sides, I get 2x cannot be equal to negative 1. If you divide both sides by 2, you will get that x can't be equal to negative half. Now they're asking you for the domain, so I will go ahead and write the domain in interval notation. You know me, guys, I always graph it. Negative 1/2 is on the left because it's a smaller number. And 3 is on the right. Open circle for both of them because they cannot be equal to these values. But it can be everything else. It can be everything else. Everything to the left of it, everything in between, and everything to the right of 3. So here's the interval notation. The very first one that I got on the left side right here. This one, that is going to be, try to match the color. Negative infinity to negative 1/2. Union. Now let's do the one in the middle. The one in the middle, I'll use the orange pen. That one starts at negative 1/2, right? Negative 1/2. And it goes to 3. Close the parenthesis, draw the union symbol. And we just got one more left. That's the purple. The purple. All right, the very last interval that starts at 3, but that one will go on forever to positive infinity. So that is how you can find the domain. But you know why I put this question on the exam? Because I want to see if you can factor a trinomial that has a leading coefficient bigger than 1. Okay, I know you guys took that pre-calculus diagnostics test, but factoring is an important skill that I want you to have in Math 161. So if you need more help with this, let me know. You and I can work together on factoring problems. But after watching this video, taking good notes, I think you should be able to try your exam problem. So that is it for number 11. I wonder if my number 4 got uploaded okay. It takes forever, guys, for YouTube to I shouldn't complain about YouTube. Or I think it got uploaded, so no one watched it just yet, but hopefully somebody watches it because you asked for it. All right, but that's it for number 11. I will wait for you to email me about